Okay, this is lesson 8.1, the sine law. Now you might be thinking, didn't we already do the sine law when we did SOHCAHTOA, like sine theta equals opposite over hypotenuse? Well, we didn't, because the sine law isn't the same as SOHCAHTOA. The sine law is actually a equation that was developed in order to solve for angles or sides in triangles that aren't right angles. SOHCAHTOA, including the sine ratio, opposite over hypotenuse, is used to solve for angles and sides in right angle triangles. So for our purposes, the sine law we're going to look at today is used in non-right angle triangles. Now, it will work in right angle triangles, but what you'll find is when you try to use it, the equation ends up simplifying to just sine theta equals opposite over hypotenuse. We end up with just the sine ratio. So they're kind of one and the same, except this is a more general case for all triangles. When can we use the sine law? Well, we can use the sine law when you want to find an unknown side if you have two angles and one side. Or you can find an unknown angle if two sides and the angle opposite one of the known sides are known. That makes it tough. Here's the key. When you're using the sine law, what you really need is, I'm going to write it, let me write it here. You need a pair plus an angle or side. And we're going to get more into what that means. A pair plus an angle or a side. And I'm going to show you what that means. Let's look at the sine law for the first time. Well, there's two versions. There's A over sine A equals B over sine B equals C over sine C. Or there's sine A over A equals sine B over B equals sine C over C. Now you might be thinking those look the same. They're just one's the upside down version, and you're right. But why are there lowercase and uppercase letters? Well, if you remember, capital letters mean angles, and lowercase is sides. So in this version, we have all the sides on top, and in this version, we have all the angles on top. Now, why would we have two versions? Well, you really just need one version, but you can make the math a little bit simpler if you know both. And if you remember what one looks like, you just flip it, and that's what the other one looks like. The key is either all the sides have to be on top or all the angles. If you have the version with all the sides on top, it makes it really easy to solve for sides. And if you have all the angles on top, it makes it really easy to solve for angles. That doesn't mean that you can't use this version to solve for angles. It just means you'll have to do a little bit more algebra first. You'll have to rearrange the equation to kind of make it look something like this. So you might as well just start from there. All right, let's look at 4 examples. And as we work through these 4 examples, we're going to kind of investigate how sine law works and how we can use it to solve for sides and angles through all of our scenarios. And we'll talk a little bit more about what this a pair plus an angle or side means. So let's look at our first triangle. We have triangle ABC. And if we label the triangle, not with opposite, adjacent, and hypotenuse, because we're not in a right angle triangle, but just by labeling sides and angles with their respective letters. Now, if we have angle A, that side is always across from side A. If we have angle B is always across or opposite side B. And if we have angle C, it's always across or opposite side C. So now we have a fully labeled triangle, ABC. It says find the length indicated to 1 decimal place. Well, the length indicated here is A. We're looking for A. Since I wrote C on there, I better highlight A. We're looking for A. So we're going to use the version of the sine law that solves for sides. And since our triangle is labeled ABC, we have a pretty easy sine law to write because it's exactly right here. So let's write it. A over sine A equals B over sine B equals C over sine C. And if you haven't thought this already, you might be thinking it now. How do we have an equation with two equal signs? Well, the reason there's two equal signs is because any of these fractions can be set equal to each other. Now, when you use the sine law, you don't use all three parts. You just use two. So you could use the A's and the B's, or you could use the B's and the C's, or you could use the A's and the C's. How do you know what you're using? It depends on what you're given. Let's look at our triangle. What are we given? Well, we're given angle A, and we want to find side A. We're given angle B, and we're given side B. We're not given any information about C. So we're not going to use the C part. We're just going to use the A part. Now, the A and the B part. Now we can fill in what we know. We don't know side A, so we'll leave it alone. Angle A is 39, so we got sine 39. Side B is 30, and angle B is 65, so we got sine 65. And now we have an equation that only has one unknown. We can just solve the equation. How do we solve? Well, we isolate. This says A divided by sine 39. To rearrange it, we would multiply both sides by 39. And what that would do is basically, it would take this and bring it up to the other side, and we would multiply. 30 sine 39 over sine 65. You might remember this as something called cross multiplication. What cross multiplication taught you was that you could take something from the bottom of one fraction and bring it to the top of the other fraction on the other side if you had a fraction set equal to a fraction. And only in that scenario. If there's like a plus 1 out here, we can't do that. It has to be fraction equals fraction. But that's how we can rearrange, and now we just have A by itself. Now we can just type this in our calculator, and that will solve for side A. So let's give it a shot. We've got a fraction, 30 sine 39 over sine 65. Let's keep in mind we need to be in degree mode, and we get 20.8. One decimal place is what it asked for, so 20.8, and we're working in feet, so 20.8 feet. Now, what if you don't have a fraction button on your calculator? Well, you can just type in 30 times sine 39 divided by sine 65, and it will give you the right answer. Okay, so earlier in the lesson I said you needed a pair. Well, what am I talking about when I say you need a pair? A pair we're going to highlight in orange. So if we go and take a look, in our first example, to use sine law we needed a pair. Did we have a pair? A pair means a side and angle that share the same letter. So we know B and B. We know angle B and side B, which allows us to complete that fraction. And it says plus an angle or side. Well, we know angle A, so that allows us to fill in angle A, and now we would just have one unknown. And that's how you know you can use the sine law. If you can fill in 3 out of 4 pieces from 2 fractions, you can use the sine law to solve for the 4th piece. With that in mind, let's try B. Question B has triangle DEF, and we have 2 angles and a side. And earlier it said if we had 2 angles and a side, we could use sine law. So let's write a sine law using the letters D, E, and F. Now, if we go back up here, A, B's, and C's, A, B's, and C's. We don't have any of the letter D, E, and F. Now we're looking for angle E, or side E, so we are going to put sides on top. So we're going to make it look like this version, but we just got to use the letters D, E, and F instead of A, B, and C. What order do you write them? It doesn't really matter as long as the pairs of letters are in the same fraction. And since we're looking for a side, we're going to put the little letters on top. I'm just going to do it in alphabetical order. So we've got D over sine D equals E over sine E equals F over sine F. And there we have a new sine law written to solve for sides. All right, let's see if we have a pair. Angle E, we don't know side E. We don't know angle D, we do know side D. I'm going to put a D here. Angle F, we don't know side F. So we might have a little bit of a problem here. We don't have a pair. So how are we supposed to use sine law? We have three things, and if we start filling in, we're just going to fill in D, E, and F. We're not going to have one complete fraction. So we've run into a little bit of a roadblock. Now, the reason why at the beginning of the lesson it said that if we had two angles and a side, we could use sine law no matter what, that's because whenever you're doing trigonometry and you know two angles, your first step needs to be find the third angle. How do you do that? Well, you can remember that all the angles in a triangle should add to 180 degrees. So if we subtract the other two angles, we end up with the other third angle. So we've got 180 minus 72 minus 49, 59 degrees. So it does require a little bit of work as a first step, but now we have a pair. Our pair is now we know D and D. So we can use that part of the sine law, and since we're looking for E, we're going to use that part of the sine law. So we do not need the F's. So we're just working with D's and E's. All right, let's fill in what we know. Side D is 57. Angle D we just found, 59. Side E we don't know. Angle E, we've got 49. And the nice thing about this sine law is the rearrange step is going to be the same every time. If you're solving for sides and you start by writing a sine law with sides on top, your only rearrange step is just going to be to bring that sine 49 up to isolate for your variable E. So we get 57 sine 49 over sine 59. All right, let's see what we get. I'm going to try it without the fraction button. We've got 57 sine 49 divided by sine 59. And we get 50.18, one decimal place, 50.2, working in meters, 50.2 meters. And there we have it. We've now used the sine law twice to solve for an unknown side. So keep in mind, if you're using sine law and you've got two angles, find that third angle first. Now, that being said, we did not do that in A. Why didn't we do it in A? Well, it wasn't a necessary step in A because we already had a pair. But if you don't have that pair, you need to subtract from 180 to find that third angle. All right, let's flip it over and solve for a side. Sorry, an angle. Draw a diagram and label the given information, then find the measure of the indicated angle in each triangle to the nearest degree. All right, we have an acute triangle ABC. We know angle A is 64, side A is 10.4, side B is 7.1. We want to find angle B. The nice thing about being given a question like this without the diagram is it's really easy to see if you have the pair. A, and A. So we got a pair, plus we have a side, and we want to find its opposite angle. This is a perfect sine law question. So how do you draw a diagram? Well, you typically draw the same triangle every single time. If you know it's not a right angle triangle, I just draw a little triangle that almost looks like an equilateral or an isosceles triangle. I just draw something like this, and then since it's ABC, I just put A, B, and C clockwise, counterclockwise, doesn't matter, on the vertices. And then if you go across the triangle, we've got A, B, and C. Scale doesn't really matter. You can try to draw it to scale if you'd like, but save yourself the time. Just draw something that looks like an isosceles or equilateral triangle, and it'll be functional for you doing this question. Now we can label on what we know. Angle A is 64, so let's put a 64 there. Side A is 10.4. Side B is 7.1. We want to find angle B. So we have our pair plus a side, and we want to complete the other fraction. This is perfect. So we're finding an angle, so we're going to write a sine law with angles on top, and our sides are A, B, and C. So our sine law is going to look like this. Remember, angles go with the sine word. So sine A over A equals sine B over B equals sine C over C. Now I've got A, B, and C. We don't need C's because we're just working with A's and B's. So you can actually get into the habit, if you know which two you're working with, you don't even have to write the third part. Now let's fill in what we know. We know angle A is 64. We know side A is 10.4. We don't know angle B, but we know side B is 7.1. Now, the rearranging step to solve for an angle is one step more. We still start by bringing the bottom up to the other side. This time we're not bringing up sine something, we're bringing up a number. Numbers go in front of sine, so we've got 7.1, numbers when they're lengths, sine 64. So basically we're multiplying both sides by 7.1. That leaves us with just sine B. And if you remember back from SOHCAHTOA, if you're solving for an angle, you need to use the inverse. Well, the inverse of sine is sine inverse. So if we want to get B by itself, we need to do sine inverse of this entire thing. And now you have two choices. You can first figure out what this is by putting it in your calculator. 7.1 sine 64 divided by 10.4 is 0.6135997.816. And then do sine inverse of that number, and we would get 37.85. Or you can do all the rearranging at once, don't calculate this, and just do sine inverse. And type the whole thing in your calculator at once. This is the way I would prefer to do it because you don't have to write any long decimal down. You can just do sine inverse right away. What would it look like? Well, it would look like this. Shift sine to get sine inverse. Now in the big bracket, 7.1 sine 64 divided by 10.4, close bracket. And we get the exact same thing, 37.85. This way I think is easier. This is the way I would suggest that you solve. To the nearest degree, let's round that up to 38 degrees. There we have it. Okay, one question left, B, and I think this is a perfect one for you to try on your own. So if you would like to give this a shot, draw triangle MNO, label it with angle M, and side N, and look for angle N. And that's going to be it for 8.1. Thanks for watching. Be sure to try that question on your own and check your answer on the course website. I'll see you for lesson 8.2.